Hi Algebra 2 students, this is a video on solving three variable systems of equations, and today we're going to be focusing on the strategy of elimination. Okay, so if you feel like you have a good understanding of elimination for variable, when we're dealing with two variable systems, then this shouldn't be so bad. The way I think about it is it's kind of like solving a couple of elimination problems all wrapped up into one, okay? And the idea is that your solution set here, now that we have equations with three variables, x, y, and z, so your solution will be an it's not just going to be an ordered pair, it's going to be an ordered triplet, because there's going to be an x, a y, and a z. So the solution will be a point x, comma, y, comma, z. And the idea is that once you have an equation with three variables, this is actually no longer an equation of a line, but an equation of a plane. And we're going to get into this a little more in class. But the idea is that this point would be the intersection of three different planes in three-dimensional space. So I'm just going to just to give you some visual representation right now of the three-dimensional coordinate plane. You can think of this as being like your x-axis, your y-axis, but then there's also a z-axis. Okay, and then you can imagine a point getting plotted somewhere in three-dimensional space that has a value for x, y, and z. Okay, but we're going to explore more of the deeper meaning in class. Today right now I'm just going to show you the procedural elements of the process. So if I give you a three-variable system of equations, usually there's going to be three equations. Otherwise, it's almost impossible or sometimes impossible to solve it. Okay, so the idea here will be, I'm going to take, for the sake of clarity, I'm going to number these, equation 1, equation 2, and equation 3. So the idea here is going to be that we're going to take equation 1 and equation 2, and we're going to solve that like it's its own new system. Okay, so we have equation 1 and 2. Okay, so that would be x plus y minus 3z is equal to negative 10, and x minus y plus 2z is equal to 3. Okay, so I'm treating this like a system of equations in and of itself, and my goal is going to be to eliminate a variable. Now, I really could eliminate any variable, but the key is I'm going to do this again using equations 2 and 3, and I'd like to eliminate the same variable both times. So if I kind of look at all three equations lined up, I notice that the y variable in each one doesn't have a coefficient in front, or the coefficient is just 1 or negative 1. So that's kind of showing me that it's going to be pretty easy to get a y variable to eliminate if I'm adding any two of these three equations. So now that I'm coming over to just looking at 1 and 2, I can see that if I add here, the y variables will cancel. So that's exactly what I'm going to do. So when I add, I'm going to get x plus x is 2x, y's cancel, negative 3z plus 2z is negative z is equal to negative 7, right? So this gives me a new equation, and now notice I only have two variables. I only have x and z. I'm going to call this one new number 1. We're going to come back to this. Okay, so we've taken equations 1 and 2 and we've added them together, right? But really you can just think this is a new system of equations. My goal is to eliminate a variable and get a new equation. And now we're going to do the exact same thing once again, but with equations 2 and 3, okay? So I take equations 2 and 3. I'm going to kind of draw my arrow going down here. And we'll see what we need to do in order to eliminate the same variable. We have to eliminate the same variable as we did when we added equations 1 and 2. Oops. Okay, so when I take a look here, I see I have negative y, positive y. So again, it's going to be pretty easy to just add. There will be times when you will need to, for example, multiply one of the equations or both of the equations to get something to cancel. But for the sake of our time, I didn't want to do that in one of these videos. So if we take a look, those will cancel. We're going to get 3x, and then we have 2z minus z. So that's going to be a positive z is equal to 3 minus 6, negative 3. So now I get a second new equation with two variables, x and z. I'm going to call this new number 2. Okay? So now that I have these two new equations and they both are only in two variables, this is going to turn into another elimination problem which I can actually solve and get numerical answers for x and z. So on this next slide, what I've done is I've just rewritten the original equation. You don't have to do that since you can probably still see it at the top of your page, but for my sake here, I just rewrote it. And then we have the new number 1 and the new number 2. These are the two equations we had in the cloud, and the two red clouds on the previous slide. Okay, so now we're going to treat this like a brand new system and just solve it like a regular two-variable system. So if I take a look here, it looks like z's will cancel most easily if I add. So when I add, the z, negative z, positive z cancels, I get 5x is equal to 4. Is that right? Oh, this 7 is supposed to be a negative 7. Sorry about that. So if we just, to confirm, we go back to the previous page, we had a negative 7 in that spot. I just didn't write the negative. So now when we add here, we get negative 10. Okay. So dividing by 5, I get x equals negative 2. So we have the first number on our point. So now that I have the first number, x equals negative 2, I can plug back into either one of these two equations right here to get a value for z. Okay, so now it doesn't matter which one we plug into, but we can't plug into an original or we won't get, because it also has the y variable, it won't give us just a number for z. So we want to plug into new 1 or 2, right? And we have our x equals negative 2, so I'm going to just plug into the first one. And I get negative 4 minus z is equal to negative 7, so I can add 4. And I get negative z is equal to negative 3. So dividing by negative 1, I get z equals 3. Okay, now I'm going to take x, I'm going to take z, or z and take x, and plug both of those into one of the original system equations. Okay? So the last step is plug in to original equation. And we can find y that way. So I'm just going to pull the first equation, which is x plus y minus 3z is equal to negative 10. So plugging in x equals negative 2 plus y minus 3 times z of which is 3 equals negative 10. So then I get negative 2 plus y minus 9 is equal to negative 10. So combining the negative 2 and the negative 9, we get y minus 11 equals negative 10, and then we can add 11, and we get y equals 1. Okay, so that might have seemed like a lot of work, but we finally now have the ordered pair, which will be our solution, and I'm going to write it as x comma y comma z. So the x value is negative 2. Oops. The y value is 1, and the z value is 3. Now, we can also check our work. Of course, we can check our work by plugging in our point into all 3 of the original equations. So that might seem tedious, but I really believe this is the best thing to do because it's very easy to make a small mistake when you're doing these calculations. So the first equation was x plus y minus 3z. So x, negative 2, plus y, 1, minus 3 times z. 3 times negative 3, does that equal negative 10? Well, I just did this, so I know it probably is going to check out. But negative 2 plus 1 is negative 1 minus 9. Will that equal negative 10? Yeah, it does. Okay. Plugging into the second equation, which was x minus y plus 2z equals 3, I'll do negative 2 minus y minus 1 plus 2z plus 2 times 3 equals negative, oh no, not negative, equals 3. Okay, so here we get negative 2 minus 1 is negative 3 plus 6. Yes, that is 3. And then for the last one, 2x plus y minus z equals negative 6. I'm doing 2 times negative 2 plus y plus 1 minus z, which is minus 3, is equal to negative 6. So I get negative 4 plus 1 minus 3, which is negative 4 plus 1 is negative 3 minus 3. That is negative 6. So my work all checks out, and I am done with this problem. Yes, it takes longer than a system in 2 variables, but it is a much more complex situation. So I couldn't leave you without a you-try problem. So I'm just going to kind of get you thinking about this. So as you approach it, you want to kind of think about which variables should you try to eliminate when you go to add equation 1 with equation 2 and then equation 2 with equation 3. So when I'm kind of skimming here, I notice that like I see the positive 2y and negative 2y, so I know if I add 1 and 2, the y's will cancel. And then I see that in equation 3 I have a 4y, and then equation 2 is the negative 2y. So that means I could multiply equation 2 by 2 to get something to cancel when I add there. Okay? So that would be my recommendation for how to get started on this problem, but do your best, and we'll definitely talk about it in class tomorrow.